So we were on this part already due to some discontinuation of net. It happened, and I would like to say ki okay. So what we were on, yeah. So what we have already done is that we had few questions. We have done on acetonitrile P1 sat and P2 sat, and total pressure was given. So what we have done, we have applied the concept of P equals to P2 sat plus X1 P1 sat minus P2 sat, and then when we solved afterwards, we used Dalton laws of pressure, Raoult's law at the same time, and we found out that Y1 is equals to X1 P1 sat by P. So going ahead with this concept, let's move on to question number 3. So you can start writing with me. The molar density of water vapor at the normal boiling point of water is 33 mole per meter cube. The compressibility factor Z under these conditions is closest to what values? Let's take some values. A equals to 0.75, B equals to, let's say, 1.5, C, and D is equals to 1.75. So please start solving this question. What you have been given, what you have to solve. It's a bit easier question. So efficiently try to solve. What we have been given to you, the molar density So normal boiling point conditions will be equals to pressure equals to 1 atm equals to how much, and you should know how to do this Pascal. If I'll say this is the concept which you have to use, so this is the concept which you have to use, and here we are trying to solve the question. And molar density, so what you say to molar density, it has been given to you as mole per meter cube. You already know the value of R, which is equals to joule per mole Kelvin. Boiling point it has said, so T equals to 100 degrees Celsius will be equals to 373 Kelvin. So one other thing which is very important to us, you should know what is, this is a basic thing which everyone should know, that boiling point temperature of water is 100 degrees Celsius and pressure is equals to 1 atm. And what is molar density? Moles per unit volume. So this has already been given to you. Please start solving this so that we can get the answer. So what Z will become? P and V by N. So it was given to you as okay. So that Z equals to, if we know it is PV by nRT, we already know if we have to write in the way it has been given to us. So we will use this, right? So Z will equals to N by V will be equals to 33 moles per Kelvin, R is equals to 8.314 and T equals to 100 degrees Celsius. So if you try solving that, you will get an answer estimate of 0.98, which is approximately equals to 1. Okay, are we on page? That what we have done at what is the formula of Z, what we have given to us, this was the molar density which has been given to us. We have tried to find out all these things and we were able to get the values. So this was a crucial part. We have been given few things as well. So let's write another problem. So this is a basic question. At a given T and P, a liquid mixture of benzene and toluene is in equilibrium with its vapor. The available degree of freedom is so it is asking few questions, that is at a given temperature and pressure, what will be the degree of freedom? So let's write what it is. So first of all, you should know what is degree of freedom. And what is its formula? So degree of freedom, if I'll write degree of freedom, is equals to C minus P plus 2. P is equals to phases, number of phases. C is equals to number of components. So how many number of components? So C equals to number of components is equals to 2. P equals to, why it is 2? This is benzene and toluene. This is number of phases. So it's a liquid mixture and it is equilibrium with its vapors. So phases is in vapor and liquid state. Both are there because it has been said it is in liquid state. So it will also be equals to 2. So if we write the formula, C minus P plus 2, which will be equals to, are you in line with me? Let's write another question. So the question says the system acetone and acetonitrile 2, comma nitromethane 3 at 353.15 Kelvin and 110 kilopascal has the overall composition of 0.45, 0.35 and 0.20 respectively. Assuming that Raoult's law is applicable to the system, what would be the bubble point pressure in kilopascal? Okay, so this is the question, that there is a system which consists of acetone, acetonitrile, nitromethane at 353.15 and 110 kilopascal, and it has the overall composition of 0.45, 0.35 and 0.2, respectively, assuming that the Raoult's law is applicable to the system. So we have to assume that the Raoult's law is applicable to the system. What would be the bubble point? Please try solving this. It's an easy question. So let's write what is bubble point pressure. So bubble point pressure, I'll write that as BPP, is equals to the saturation pressure of 1 Isn't it very easy now? So from steam table, we know that P1 sat at 353 Kelvin and 110 Pascal. Kilopascal. P1 sat of acetonitrile basically. Acetone is equals to 195.75 kilopascal. P2 sat is equals to 97.84 kilopascal, and P3 sat is equals to 50.32 kilopascal. Okay, so now can you solve this? It is very easy now. X1, if we'll see, let me write, and you know X1, X2, X3 has already been given to her. So how much X1 has been given to us? 0.45, 0.35 and 0.20. So these are the values, and you just have to apply a basic formula that we need to know the partial pressures, the saturation pressure of all these things. Since Raoult's law is applicable. So because of Raoult's law. Okay. So if I'll solve this, how much I will get? X1 is 0.45 into 195.75 plus 0.35 into 97.84 plus 0.20 into 50.32. Can you solve this? The answer will come around to be this much. This is the answer. So since Raoult's law were there and we know the concept already and we had the partial pressures, so we know that at bubble point what will happen. Okay, so let's move ahead with question number 6. Okay, so a small question. The necessary and sufficient condition of thermodynamic equilibrium between two phases is. You should remember this actually. Like what is? Is it? The concentration gradient should be 0. The temperature should be 0. Delta P equals to 0. Or the last thing, mu should be 0. Answer is D. Chemical potential of each compartment should be same in two phases. Are we in line? Okay. Let's take another question. The second variable coefficient of a certain gas is given by B equals to B minus A by T square, where A and B are constant. The change in internal energy. For this gas, in going at temperature T0 from very low pressure to a pressure pi would be question. So a hint for you, use equation Z equals to PV by RT is equals to 1 plus BP by RT. Okay? This is a very good question, a crucial question. So the question is asking, okay, so did you try? So what the question wants, they want delta U equals to from 0 to pi. What you have been given, that we already know this is equals to, and the second variable coefficient b equals to b minus a by t square. And this is at T naught temperature. So we already know D equals to TdS minus PdV. So del U by del P, because and that too at a constant T, will be equals to minus del by del P. Are you guys with me? And from Maxwell, relation, this will be equals to minus del V by del T at SC minus del V at del P at, okay. So we are right now here. Let's go ahead. As V is equals to RT by P plus B, taking B as the given equation, we will get del U del V so del V by del T So now we have to find del V by del T for equation 1 and del V by del T at constant pressure. So del V by del T will become plus two A by dq, and del V del P at constant temperature So if we know, so our already from equation 1, 2 and 3, putting the value of 2 and 3 in equation 1, how much it will be? P into R by P plus 2A by T cube. Okay. And this was minus P into into minus RT by P square. This will become T naught cube, T naught square. At T equals to T naught will become T naught square. So from 0 to pi, low pressure equals to 0. So from 0 to pi, this will be equals to minus 2a pi by T naught square. This is our answer. Let's go to question number 8. So what does our question number 8 says? Let's see. So question number 8 says, so let us consider a binary solution formed by two components, one and two. If G1E is the axis gives free energy, of 1 at x1 equals to 0.3, and G2E is the axis gives free energy of 2 at x2 equals to 0.5, then what is the ratio between them? That is the activity of the above two components are given as 1.2 for component 1 and 1.5 for component 2. So let's start this. We already know GE by RT is equals to sigma of Ln gamma I. So G1E by RT is equals to x1 of ln gamma 1 plus x2 of ln gamma 2. And what we know, we already know that x1 is equals to 0.3, x2 is equals to 0.5. Okay, so just trying to put, so let's see G1E by G2E. So same way, ln of gamma 1 plus 1 minus x1 of ln gamma 2. And here it will be in terms of x2. So this will be equals to ln gamma 1 plus x2 into ln of gamma 2, which is equals to so if we'll compare this G1E by G2E, it will be equals to 1.15. Nothing you have to do, you just have to remember this is the concept. Okay, this was the concept. This was the concept. Okay, and you have already been given x1 and x2, right? You have already been given, so you just have to use that concept, and you should know x1 plus x2 equals to 1. So in this, 1 by x1 and x1 will be equals to 1 minus x2. So this thing you have to apply and you will be on board. Let's take another question. So let's grasp this question, and let's start with another question. At 25 degrees Celsius and 1 bar partial pressure, the solubility of ethane is water is very small. By the way, this is the most very important question. So we will slowly will do. The equilibrium mole fraction is given by So the question is asking what is it? I hope you are done with this question and we can move to this question. At 25 degrees Celsius and 1 bar partial pressure, the solubility of ethane is very small. Ethane in water is very small. The equilibrium mole fraction is given this. At 25 degrees Celsius, compressibility factor is given. So now if they have changed partial pressure to 35 bar, what will be the solubility? Are we on line? So it is asking. So I'll be like explaining each and every part of it. So I'll be writing each and every part rather than right. So at equilibrium, what happens if your gasicity coefficient is equal? Now, since at 25 degrees Celsius and 1 bar pressure, the solubility of ethane in water is very small, we can consider Henry's law. To be valid. So this is our concept. And by Henry's law, what it is, Fi liquid is equals to Henry coefficient into H into Xi, which is equals to, therefore FIL is equals to Yi into P. Here I is ethane. And at 1 bar, Yi is approximate. And since Psat of water is very small, that is 0.0316 bar at 25 degrees Celsius, what we will consider water to be non-volatile. At 25 degrees Celsius, therefore Yi is equals to 1. So P equals to H into Xi, which implies S equals to P by Xi, that will be equals to 0.33 into 10 raised to power minus 4 equals to 3 into 10 raised to power 4 bar. So 35 bar ln of phi I is equals to Z minus 1 by P from 0 to P dP. And we have been given Z is equals to 1.763 into 10 raised to power minus 3P minus 7.22 into 10 raised to power 5P square. Ln of phi I is equals to 0 to 35 minus 3 to dP, which is equals to, now only you have to solve it. And as we know, phi I P equals to Xi Hi, which implies Xi is equals to option D. Okay, so now it was a basic question. Here the main concepts were here, that if it is small, so it will be non-volatile. If it is high, it will be volatile, and here it will go. It was an easy question, but if you'll see it with that perspective, that it was a good question in terms of so this is a homework question. This is a one answer question in a binary solution. If molar volume of one of the components increases with concentration, the molar volume of the other question mark. A is constant, B is decreases, C is increases, D is same. Okay, so now just let's revise it, our paper, that we have done so many questions today, and where we have found out that two fugacity mixtures have been there. So my name is Vidya Sharma. So I will meet you again in week 5. Till that time, please take these help of these notes and try to solve every question, which will be helpful for you. And we will meet soon. I have done maximum of these questions, so we will meet again whenever there'll be the week 5 lecture, that is next Tuesday. So hopefully everything will go fine. In week 5 I will also take a few assignment questions in that. This I will upload on YouTube, and we will meet soon. Thank you.